Today we are going to learn what is group, subgroup, class and order based on group theory. First, what is meant by group? A group is a set or collection of elements which are combined with certain operation, that is identity operation. The second one is inverse operation. Third one is associative operations. The last one is the group is closed under the operation, means it undergo addition, subtraction or multiplications. The next, the set of elements together with our operations, that is multiplications, addition or subtraction, that combines any two of its elements to form a third element and also satisfy the four properties of a group also. The four properties are closure, associativity, identity and inverse property. Why we have studied the symmetry elements in group theory? Because each molecule has a set of symmetry operation that describes the molecule's overall symmetry. This set of operation defines the group of the molecule. For example, I want to do an operation of addition using the integers. For example, -3 plus -2 gives -5. This -5 is also belong to this integers. Okay. Next, the properties of a group. The first one is closure property. Okay. The product of any two elements in a group and the square of element must be the element of the same group. Okay. For example, the result of combination of two or more elements or square of the elements must be equivalent to one element of the group. Okay. For example, A, B, C. The three elements belong to the group G, means the product of the symmetry elements A, B gives C. So the C is also belong to the group G. Okay. The next one is associative property. The combination of two elements may or may not be commutative, but it must be associative. For example, A of BC is equal to AB of C is equal to ABC. Okay. The next one is inverse property. The inverse of every element should also be a member of the group. Okay. Each and every element in the group must have an inverse. Okay. For example, A of X is equal to X of A is equal to E. That is, A is identity element. In this equations, A is the inverse of X. Okay. The next, last one is, that is identity property. Okay. Identity, a group should have an element that must commute with all other elements and leave them unchanged. Okay. For example, A is multiplied with the identity element E. It gives the element A. Okay. And B of E is also give the element B. The next, C of E is also give the element C. Okay. Next, how do we prove that properties of a group? The first one is the product of any two elements of the group is itself on the element of a group. For example, we have to take the molecules of ammonia. The ammonia molecules belong to C3b point group. Okay. So, the C3b point group has 6 symmetry elements. Okay. What are they? The identity, C3 prime, C3 double prime, sigma V double prime, and sigma V triple prime. Okay. I want to designate the hydrogen atom in the ammonia molecules. I will take the symbol of 1, 2, and 3. Okay. Next, I want to perform, that is multiplication of any of the two symmetry elements in C3b point group. I have to select, that is sigma V double prime and C3. Okay. So first I perform the C3 operation in ammonia molecules. Next I perform sigma V double prime. Okay. First I have selected the ammonia molecules H1, H2 and H3. Okay. I perform the C3 operation in ammonia molecules. All the hydrogen atoms are changed their place. See that the H1 will be changed the position from this place to this, and H2 will be changed from this place to H3 place. See that? Next, I have to perform sigma with double prime. Sigma with double prime means we have to setting the plane according to this nitrogen and H2 atoms, and the position of H3 and H1 will be interchanged. See that H1 and H3 will be interchanging. Okay, this symmetry, okay, this molecules will appear from the original molecule by performing the operation of the sigma V. For example, the original molecules of ammonia molecules are performing the sigma V by putting the plane from N to H1. So the place of H2 and H3 will be interchanged. Both the symmetry are equal. So the sigma V double prime in C3 operation will give the symmetry element of sigma V. This sigma V is also present in the group C3V. Okay. The next one is the associative law. For example, the element of a group is P, Q, R. Okay. The P of QR is equal to PQ of R. Okay. How do we prove that? First, selecting a C2V point group. Okay, C2V point group. C2V point group present in water molecules. We are very well known. First, we have to perform that operation of sigma V single prime C2 sigma V. Okay, that is similarly P, Q, R. Okay, next sigma V single prime. Okay, is multiplied with C2 into sigma V. Next, sigma V single prime C2 is multiplied with sigma V. For example, in C3V point group, okay, C2 axis is passed through Z axis, and we have to fix in the plane, that is horizontal plane, sigma V prime, and the vertical planes from 1 and 2. Okay, the 1 is designated as the plane of sigma V, and 1 and 2 is the name of hydrogen atoms present in water molecules. The symmetry elements in the C2V point group is E, C2, sigma V in X Z axis, and sigma V prime Y Z axis. Okay. First, we have to perform this PQR, that is sigma V prime C2 sigma V. Okay. By performing C2, that is sigma V, that is 1, 2 will be interchanged to 2, 1. Okay. So sigma V single prime C2 into 2 into 1. So next sigma V primes will be multiplied with C2 operation. This C2 will interchange the position of hydrogen atom 1 and 2 from 2, 1 to 1, 2. Finally, the sigma V single prime will be involved in the symmetry operations by giving the arrangement of 1 and 2. Okay. The next sigma V single prime is multiplied with the C2 of sigma V. Okay. The sigma V is placed 1, 2. Okay. So we are performing sigma V means that is 1, 2 will be changed to 2, 1. Okay. The sigma V single prime C2 into 2, 1. Okay. The next we are performing C2 operation. C2 operation will interchange from 2, 1 to 1, 2. Next sigma V prime will also change from 1 to 1, 2. Okay. So next sigma V prime C2 of sigma V. The sigma V is 1, 2. So we are interchanging the sigma V 1, 2 is horizontal plane. So again we have the same symmetry 1, 2, and again sigma V single prime and C2 will also follow the rules 1 of sigma V single prime C2 is equal to sigma V. So sigma V of sigma V in the plane change 1, 2 to 2, 1. Okay. Finally we got 1, 2 change. The next property is identity element. So one element in the group must commute with all other elements in the group and leave them unchanged. For example, the identity element E is multiplied with the element present in the group, okay, the element X, and also this identity element multiplied with the element X. So that is E into X or X into E is always give the element X. Okay, that is the matrix form of that identity element 1 0 0 0 1 0 0 0 1. This is the axis belongs to that identity. Okay, that is symmetry element x1 y1 z1. So we have to perform this row and column addition. Okay, that is multiplication 1 into x1, okay, 0 into y1 plus 0 into z1. So similarly 0 into x1, 1 into y1 plus 1 into 0 into z1. So similarly we have to perform in this multiplication operation. Finally we got that is x1 y1 z1. Okay, so the symmetry elements of the matrix forms will not be unchanged by performing the commutative operations. Okay, the next, for every element there exists on inverse. One element in the group must commute with other element to generate the identity element. For example, x into x inverse or x inverse into x always give the identity element E. For example, we have to select the C2 point group of water molecules. We all very well know the C2V point group has the symmetry element of E, C2, sigma V in X Z axis, sigma V prime in Y Z axis. So we have to performing the symmetry element in C2V point group, that is E into E is equal to E, and again C2 into C2 is equal to E. Next, sigma V into sigma V is also give E, and sigma V prime into sigma V prime is also give identity element E. So from this we have concluded that every symmetry element in the group have the inverse property. Then next, the classifications of a group. The first one is abelian group. Okay, all elements are commutable. Okay, for example, we have to take in the example of water molecules. Okay, first we performing the C2 operations. The H1 and H2 place will be interchanged, and we have to fix the plane sigma V. So we have to play sigma V. Thus, there is no change in the molecules. Okay, so all the elements are commutable with each other. The second one is non-abelian group. Okay, all elements do not commute with each other. For example, phosphate having the symmetry operations, there is symmetry element E C1 3 and C3 4 and sigma V1 and sigma V2. The multiplication of C3 into sigma V is not equal to sigma V into C3. The third one is cyclic group. In cyclic group, all the elements of a group can be generated from one element. It is denoted by the symbol A power n. Okay, A is represent the identity element and n represent the total number of elements, and it is also called the order of a group. Okay, so next important point is that each cyclic group is abelian, but each abelian group is not cyclic one. Okay, this question is asked in CSIR for every time in group theory. So next example, this that is trans 1,2-dichlorocyclopropane is belong to cyclic group. Next, classes. Okay, what do you mean by classes? This class is also the subdivision of a group. Okay, group subdivision of a group. Two elements, that is A and B in a group, form a class if they are conjugate to each other. So the conjugate elements are related by the following equations, that is x power minus 1 into A into x is equal to B. Here the x's undergo the similarity transformation. Okay, similarity transformation. So that we have got the product of B. This B is also belong to the group. Okay, For example, water molecule has the symmetry elements E, C2, sigma V and sigma V prime. Okay, have to multiply it with the C2, okay, with their complex conjugate, and we have to got the symmetry elements present in the C2V point group also. The next, order and subgroup. The order of a class of a group must be an integral factor of the order of a group, and the number of elements is called the group. Simply we say that the number of elements present in the group is called order. Okay. A subgroup is a smaller group within a group. Okay. A subgroup is a smaller group within the group, and it is also obey the 4 fundamental properties of a group. Okay, the identity operation is E always belong to the subgroup by itself. So the ratio of the order of a group, okay, designated as a symbol G, to the order of subgroup S is always form an integer. That is G by S is equal to integer. For example, you have to take the order 6 in this point group, have the symmetry elements E, a, B, C, D, F. So we have 6 symmetry elements in the group. So the order of the group, that is H, is equal to 6. Okay. The subgroup will always A, B, C, R, B, C, D, R, D, F, E, anyone. Okay. Next, how do we prove this subgroups also within the group itself? Okay. Again, we have to select the order H, that is order 6 example. That is the rule. The product of any 2 element of the group itself is an element of the group. So it is also obey the associative law, and it is also having the identity element. For every element that exists on inverse also. Okay. For example, by weaving this box, this multiplications of E and E will give the product E. So the order of the group will be 1. Okay. So this E will belong to the group. So it is also called a subgroup. Okay. The next we have to watch this blue box. So here the A into E will give the product E, and A into A will give the product E. So this group, okay, this group is also have this, okay, have the order 2, okay, because it has the element, that is symmetry element A and E also. So it is also belong to group. So we have to say this is a subgroup. Okay. The next, this group, so B is multiplied with E gives B. B is multiplied with A give F. B is multiplied with the B is give E. But we have got different symmetry elements in the group. So the order of the group is 3, but this is not belong to subgroup. So next, C3V point group. C3V point group has the 6 symmetry element E, C3, C2 square, sorry, C2 sigma V single prime, sigma V double prime. Okay. The order of the group is 6. The subgroup will be 3. Okay. See that this is the order of the group is 1. The second one is, it is also belong to subgroup. The second was belong to the order 2. But it is not a subgroup because the multiplication of C3 E will give C3, but C3 into C3 will give the different element in that group C3 square. So it does not belong to the subgroup of the element is 3. Okay. The next, it is also having the order 3. It is also belong to the group and obey the subgroup properties also. Thank you.